right, so for this guy, the first thing they want us to do is to sketch the slope field at each of these. I think there's 9 points. I think they do want us to put them on the y-axis here. I'm going to do it just in case. So first of all, wherever x equals 0, my slope will be 0. So those points will just have this little horizontal tangent line. And then I just plug in, like the point 1, 1 gives a slope of 1/2, so that's there. The point 1, 2 has a slope of 1, and the point 1, 3 has a slope of 3/2. So you just want to make sure your slopes get a little bit higher each time. Then on the negative side, the slope here is -1/2, then -1, and then -3/2. So you really want mirror reflection slopes on either side of the y-axis. Part 2 is asking about Euler's method. They're saying, let some function be the particular solution with an initial condition f of 0 equals 3. So let's use Euler's method table, starting with the point 0, 3, and I need the slope that I'll get from plugging in to dy dx, and that slope will be 0 because my x value is 0. Then I need my tangent line equation, which with the slope of 0 is just y equals 3. Then I need a new x value, and I'll need a new y value. Sorry for my writing, that's new y over here. New y. So new x, step size was 0.1. So my new x is 0.1. Plug that into my tangent line, I still have a y value of 3. By the way, it says to do approximate f of 0.2, so I just need 2 steps. So this is my first step. So now my second step, I bring over my new x and my new y from here to my second row. And I plug these into the slope. So 0.1 times 3 is 0.3 over 2 is 0.15. So my tangent line is going to be a slope of 0.15 and then x minus 0.1 plus 3. My new x value is 0.2. If I plug that in for x there, I get 0.15 times 0.1, which is 0.015. And my new y value is 3.015, which is the answer to part B. Part C says, find the particular solution to the given differential equation with the initial condition f of 0 equals 3. So this is a separate, integrate, solve question. So I'm going to start by separating the variables. I'll have dy over y equals 1/2 x dx. Then I have to integrate both sides of the equation. So I'll get ln, the absolute value of y, equals 1/4 x squared plus c. Then I'm going to need to exponentiate both sides of the equation to be left with the absolute value of y equals, I'm going to take, well, I'll just rewrite e to the 1/4 x squared plus c is still up in the exponent. And then when I absorb my absolute value, and I'll start over here, absorb that absolute value, rewrite that coefficient as a, so you'll have ae to the x squared over 4. Now I'm going to plug in this initial value of 0, 3. So I get actually that just means my a value is 3. So if I plug in x equals 0 and y equals 3, then a is 3. So then they're asking me to use this to evaluate, or to evaluate f of 0.2. All I can do here is plug in a 0.2. I have e to the 0.2 squared, which yes, I could do even in my head, but then I can't do, e to the 0.2 squared over 4. So I'm just going to leave it like this. If in your answer key it has this worked out to be a decimal approximation, then they used a calculator to do it. And you could have left it like this on the AP exam and a non-calculator exam.